Hello all. In my previous lecture, I start with a transistor, and one of the classification of the transistor is BJT, right? And classification of the BJT, that is NPN BJT and PNPN BJT, right? Next, mode of BJT and also current flow in the BJT, right? And I'm continuing this topic actually, that is large signal common base current gain. That is alpha, right? See all of you. What is a large signal? Actually, large signal is nothing but DC signal. Actually, AC signals are small signals. Large signals are nothing but DC signals. Common base. Common base means base is common. So that means input is given to, in case of common base, input is given to emitter and output is taken from collector, right? Current gain actually, right? See here, what is loss signal common base current gain actually? Loss signal common base current gain is nothing but it is the ratio of negative sign of change in collector current to the change in emitter current. Change in emitter current. This emitter current changes from 0 to I. This is what actually loss signal common base current gain, right? Now here, if emitter current equal to 0, because it will changes from 0 to I, right? If emitter current equal to 0, see here, if emitter current equal to 0 means IP is 0, IPC is 0, IPC 0 means what should be the collector current? Actually the collector current is nothing but IC naught. If emitter current equal to 0, right, then collector current is equal to IC naught, right? Similarly, if emitter current is not equal to 0, if emitter current is not equal to 0, then what should be the collector current? Actually the collector current is nothing but minus IPC plus IC naught, right? Now what is delta IC actually? Delta IC is nothing but IC naught minus of IPC plus IC naught. Here IC naught cancel. Then what is the delta IC value? Actually delta IC is nothing but IPC, right? Now see all of you. Now what is alpha here? Alpha is nothing but minus delta IC. Delta IC is nothing but what actually? IPC. And delta I here changes from what actually? 0 to I, right? That means delta I is nothing but 0 minus I. Now what is alpha here? Alpha is nothing but IPC by I. This is the loss signal common base current gain. See, this can be written as IPC by IPE into IPE by IE, right? What is this IPC by IPE actually? It is a ratio of majority carrier current at the collector junction to the majority carrier current at the emitter junction. This is nothing but a transport factor, that is beta star, right? What is IP by IE? IP is nothing but majority carrier current at the emitter junction to the total emitter current is nothing but emitter efficiency, that is gamma. Now tell me what is the relation between transport factor and emitter efficiency? Alpha equal to beta star into gamma. Very, 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 very important relation, right? See, for an ideal transistor, if beta star equal to how much? 1 and gamma equal to how much? 1. Then what should be the alpha actually? Alpha is nothing but 1 into 1, 1. See, in case of ideal transistor, what should be the loss signal common base current gain value? 1. Right? Yeah. Copy. Write down. Write down the definition. Write down the definition. It is the ratio of. It is the ratio of negative sign of change in collector current to the change in collector current to the change in emitter current. Change in emitter current in bracket 0 to IE. 0 to IE. Right? That is alpha equal to, yeah, copy this one. Copy the derivation. Right. Next topic. Relation between, next topic, relation between alpha and beta. Right. First, I can define alpha. What is alpha actually? Alpha is nothing but common base current gain. That is, it is the ratio of change in collector current to the change in emitter current. Yeah, neglect negative sign actually, consider only magnitude. Right? Now, similarly, what is beta here? Beta is nothing but it is a common emitter current gain. Alpha is nothing but common base current gain. Beta is nothing but common emitter current gain. That is, it is the ratio of change in collector current to the change in base current. Right? Okay. In a transistor, what is the relation between emitter current, collector current and base current? Delta IE equal to delta IC plus delta IB. Right? Now what is an alpha? Alpha equal to delta IC by delta IC plus delta IB. Now common the delta IC value here, 1 by 1 plus delta IB by delta IC. Now what is the delta IB by delta IC actually? This is simply a 1 by beta. Now which is equal to 1 by 1 plus 1 by beta. Right? Now what is an alpha? Alpha is nothing but beta by 1 plus beta. Now what is in terms of beta? Actually beta is not in terms of alpha actually. Beta equal to alpha by 1 minus alpha. Right? See, for an ideal transistor, In case of ideal transistor, what should be the alpha value? 1. Then what should be the beta actually? The beta is nothing but how much? Infinite. That means, right? So here, that means what we can understand from the statement actually, see here, to select the best transistor, to select the good transistor actually, the beta should be very high, right? For an application. Copy relation between alpha and beta. Right. Next topic, expression of IC. Expression of IC, right. Tell me, see here in case of PNP transistor, what is the collector current actually equation? Collector current IC is nothing but minus IPC plus IC naught, right? So consider this one as equation 1. Similarly, what is alpha actually? Alpha is nothing but what actually? IPC by IE, right? So from this, what is IPC here actually? IPC is nothing but alpha into IE. This is equation 2. Substitute equation 2 in equation 1. Then what is the collector current actually? IC is equal to minus alpha into IE plus IC naught. This is the one expression of IC in terms of alpha. One expression of IC in terms of alpha. Right? Similarly, I can also express in terms of beta also. See for that, consider relation between IE, IB and IC. See the figure actually. Here what is the relation between IE, IB and IC? Here IE is the entering current, IB is the entering current, IC is the entering current actually. Right? Here you have a doubt actually. Actually, a transistor, if the two currents are inward means the third current must be outward. Right? But here I am considering all currents are inward because here actually the current in a transistor is a conventional current. That current will depend on what actually? Applied voltage. Applied voltage. Depending upon applied voltage actually the direction of the current will be changed. Right? That's why just to avoid the confusion actually you don't know whether the current is going in this way or in this way. Right? Am I correct or not? Because it depends on what actually applied voltage. Just to avoid the confusion, here I consider all currents are inwards, or you may consider all currents are outward also, no problem. Right? Next, see from this figure, what is the relation between emitter current, base current and collector current actually? IE plus IB plus IC is equal to 0. From this, what about IE here? IE is nothing but minus of IC plus IB. This is equation 4. Consider as this one as equation 3. Right? Now, substitute equation 4 in equation 3. Now, substitute equation 4 in equation 3. That is, IC is equal to minus alpha into minus of IC plus IB plus IC naught. Now IC is equal to alpha into IC plus alpha into IB plus IC naught. Now 1 minus alpha into IC is equal to alpha into alpha into IB plus IC naught. Now what about IC here? IC is nothing but alpha by 1 minus alpha into IB plus 1 by 1 minus alpha into IC naught. What is the value of alpha by 1 minus alpha actually? This is simply a beta. What is the value of 1 by 1 minus alpha? This is simply a 1 plus beta. Now what will be the collector current actually? IC is equal to beta times of IB plus 1 plus beta into IC naught. This is the collector current in terms of what actually? Beta. This is the collector current in terms of alpha. That is the collector current in terms of beta. Right? Copy. This is the expression of IC. Copied, right? And next topic, ICO. The next one is ICO. What is ICO, you know? ICO is nothing but it is the collector current. ICO is nothing but what actually? It is the collector current. Okay, when base is open. So it is the collector current when base is open. Base is open means what should be the base current actually? 0. Right? See, if the base current equal to 0, means what should be the collector current actually? The collector current is nothing but 1 plus beta into IC naught. This is the ICO. Right? Similarly, ICBO. Right? What is ICBO actually? ICBO is nothing but it is the collector current. It is the collector current when emitter is open. Right? If emitter is open, IP is 0, IPC 0, then what should be the IC actually? IC is nothing but IC naught. This is what actually? ICBO. Right. Next topic. The next topic, relation between ICO and ICBO. What is the relation actually? ICO equal to 1 plus beta into, what is IC naught value actually? IC naught is nothing but ICBO. Right. This is the relation between ICO and ICBO. This is in terms of beta. I can also express this equation in terms of alpha, that is 1 by 1 minus alpha into ICBO. Right? Write down the notes. ICO. It is the collector current. When base is open. It is the collector current when base is open. Right? Yeah. Copy this one. Right. Next one, ICBO. It is the collector current. When emitter is open. It is the collector current when emitter is open. Yeah. Copy this one. And also copy relation between ICO and ICBO. Yeah, copied now? Yeah. Written a question in classroom workbook, question number 1. Written a question in classroom workbook, question number 1. Question number 1. Right. Written a question. In a transistor, beta equal to 49, beta equal to 49, comma, emitter efficiency is 0.995, 0.995. Calculate base transport factor. Calculate base transport factor. Right. Yeah, all of you read the question once. What is the given data? The given beta equal to 49 and gamma is nothing but 0.995. Right? What we want to calculate here? Transport factor. Base transport factor is nothing but beta star. Right? Yeah. Actually, what is the relation between transport factor and emitter efficiency? Actually, alpha equal to beta star into gamma. But they given beta, right? First calculate alpha from this beta. We know alpha equal to beta by 1 plus beta. Beta is 49, right? 1 plus 49. So which is equal to how much? 0.98. Right? Yeah, now I got beta. Now what is transport factor actually? Transport factor is nothing but alpha by gamma. Alpha is nothing but how much? 0.98 and the emitter efficiency is nothing but 0.995. So which is equal to how much? 0.984. Copy. This is question number 1. Classroom workbook. Yeah. Next, question number 2. In classroom workbook, question number 2. Question number 2. In a transistor, alpha equal to 0.98, alpha equal to 0.98, IC not equal to 10 microampere, IC not equal to 10 microampere. Calculate ICEO. Calculate ICEO. Right. Right. All of you read the question once actually. Question number 2. Alpha is nothing but 0.98 and IC naught is nothing but 10 microampere and we want to calculate ICO, right? Any relation between ICEO and IC naught actually? Yeah, we have a relation, that is ICO equal to 1 plus beta into IC naught. But what is 1 plus beta in terms of alpha actually? 1 by 1 minus alpha into IC naught. Now substitute alpha and IC naught. Alpha is nothing but they given 0.98 into IC naught 10 microampere. So which is equal to how much? 500 microampere. Yeah. Copied now? Yeah. Next topic, early effect or base width modulation. Copy the figure. Yeah. See, early effect or base width modulation. First of all, why it is named as early effect actually? Because it was proposed by James Early. That's why it is named as early effect. Or base width modulation. Modulation means what actually? Change. Which one it changes here? Base width it changes. Yeah. Why base width it changes? See all of you. Here when the reverse voltage is increases at the collector junction, when the reverse voltage is increases at the collector junction actually, what happen actually? Depletion region is increased. You know that increasing depletion region can be penetrated into which side? Base side, because the base is lightly doped, right? Base is lightly doped, due to which the base width is decreases. Yeah, here the base width is decreased due to increasing of the reverse voltage is called as what actually? Base width modulation or early effect. Right? Now from this, how much base width is decreased actually? See all of you, that is WB dash is nothing but WB minus W, right? Where WB is nothing but what? Effective base width. Effective base width. And what is W? total base width. And what is W? Depletion width. Right. Yeah. Copy. Copy. When the reverse voltage is increases at the collector junction, head on the notes. When the reverse voltage is increases at the collector junction, then depletion region is increases across the junction. Then depletion region is increases across the junction. Next point. This increasing depletion region can be penetrated into base side. Since base is lightly doped. Right. Due to which the base width is decreased. Therefore, the base width is decreased. Due to increasing of reverse voltage is called as base width modulation. Right. And copy this one. Yeah, next one. See, here reverse voltage increases at the collector junction, base width is decreases. So what happened? It is a advantage or disadvantage, right? See here, it is a disadvantage actually, right? See, this early effect or base width modulation, okay, may cause 3 side effects. How many side effects? 3 side effects to the BJT actually. Yeah, what are those actually? The side effects are, the first side effect is alpha is increases, and second side effect is emitter current is increases, and third one is punch through or breakthrough. These are the 3 side effects actually, right? Yeah. The first, why alpha increases? The first question actually, how alpha increases? Okay. How this increasing alpha side effect to the BJT? See all of you. The first one. See here, first one, alpha increases. Yeah. How alpha increases? See here, if the VCB is increases, what happens? As VCB increases, what about the base width actually decreased? If the base width is decreases, what about number of recombinations within a base region? Number of recombinations in a base decreases, right? If number of recombinations within a base is decreases means what happened to the transport factor actually? Transport factor is increases. If transport factor increases means what about alpha? Increases, because we know alpha equal to beta star into gamma. right? You know, this increasing alpha due to early effect is a small value, but it produces the large beta. Yeah, see here how it produces large beta. For example, if alpha changes from 0.992 0.992, right? See, actual alpha this is, because of early effect it will changes to this value, means very small value. But what about the beta here? The beta is changes to 98 to 124. See, very large value. Yeah, which is undesired. Why undesired actually? Actually, what is a beta? Beta is nothing but it is a manufacturing parameter. That beta can be decided by whom? Manufacturer, right? But here, okay, during an operation of BJT, the beta value is changes. The beta value is changes here, right? Okay, beta value changes. That means which is desired or undesired? Undesired. If the beta changes means total our desired characteristics of transistor will be changes, because I am designing an application. I am designing an application with a beta value of 98. But what happened to due to early effect? Actually, I will get a characteristics of beta of 124. That means this is undesired or desired? Undesired. That's why this is the one side effect to a BJT, right? Yeah, copy. Copy. Write in the notes. The early effect causes three side effects. The early effect causes three side effects. The first one, alpha increases. Alpha increases. Second one, emitter current increases. Emitter current increases. And third one, punch through or breakthrough. Punch through or breakthrough. Yeah, heading the first one, alpha increases. The first one, alpha increases, right? Write down this flow graph. Only flow graph. I will tell you this one. Only flow graph. After this only. Yeah, write down. The increasing alpha due to early effect is a small value. The increasing alpha due to early effect is a small value, but it produces large beta. For example, if alpha changes from 0.99, if alpha changes from 0.99 to 0.992, here 0.992, but beta changes from 98 to 124. Beta changes from 98 to 124, which is undesired. Right? This is the first side effect. Yeah. And the second one, emitter current is increases. Yeah. See, first how emitter current is increased. See, all of you, what is emitter current actually in case of PNP BJT? I think it is IP, right? Already we derived I is approximately equal to IP, right? What is this IP? This IP is nothing but current at the emitter junction. Emitter junction is operating it at forward bias or reverse bias? Forward bias, right? Forward bias means this IP is a diffusion current or drift current? Diffusion current. Am I correct or not? Current at the emitter junction is a diffusion current because it is a forward bias. This IE equal to IP. This IP is nothing but what? Diffusion current. Diffusion current, right? This diffusion current will depends on what actually? Concentration gradient, that is dP by dx, right? dP by dx. Now, as VCB is increased, as VCB is increases, what happened to the base width actually decreased. Base width means WB dash is, right, decreased. Okay. See here base width is decreases means I think delta x is decreased. If delta x is decreases means what happened to dP by dx actually? Increased. dP by dx is concentration gradient is increases means IP is increased. If IP is increases means what about IE increased? Right. Now I, in this way IE is increased. Now tell me here how this increasing alpha is side effect to a BJT. See here, actually what is IE? IE is nothing but what? Current at the emitter junction, right? IE is nothing but current at the emitter junction. What is VCB? VCB is nothing but voltage at the collector junction. That means if you are varying the voltage at the collector junction, current at the emitter junction will be changes. That means both this collector junction and emitter junction both will be interacting. Okay, both will be interacting, na? So means both will be interacting, which may chance to change the biasing conditions of the BJT. Okay, means chance to change the biasing condition means, for example, you are fixing this emitter junction as forward bias. Because of this VCB, okay, this IE changes na, okay, it may chance to goes to reverse bias. That means here the transistor malfunctioning actually. Am I correct or not? You are fixing the forward bias, but you are fixing the forward bias, but it may chance to go reverse bias because of what actually? Changing, increasing of emitter current, right? This is one side effect to the BJT actually, right? Copy, copy. Second, when emitter current is increases. Yeah, right on. Right on. When voltage at the collector junction is increases, when voltage at the collector junction is increases, current at the emitter junction is increased. Current at the emitter junction is increased. That is both collector junction, that is both collector junction and emitter junction are interacting each other. Interacting each other, which may chance to change the biasing conditions of BJT. Biasing conditions of BJT. Biasing conditions of BJT, which is undesired. Which is undesired, right? This is the second side effect. And third one, punch through or breakthrough. And third one, punch through or breakthrough. Yeah. What is punch through or breakthrough actually? See here. See when the reverse voltage is made to very high. Yeah. If you maintain this reverse voltage as very high, what happen actually? You know this depletion region fully occupy the base. The depletion region fully occupy the base. Yeah. Depletion region fully occupy the base. Na? Depletion region fully occupy the base. Then what happen actually? Depletion region fully occupy the base means I think what about the effective base width actually? The effective base width is almost or zero. Right? If effective base width is almost all zero means what should be the concentration gradient actually? The concentration gradient will be how much? Infinite. Right? It is infinite means I think what about the IP actually? IP also infinite, right? IP is infinite means what about emitter current also infinite. That means the infinite currents are flow through this BJT. If infinite currents are flow through the BJT means what happens? The BJT may chance to damage. The BJT may chance to damage. Am I correct or not? Or we can also say whenever the depletion is in fully occupied this base means actually here what happen actually strong electric field is forming actually. This strong electric field may chance to break down the BJT actually. Yeah, this phenomena is called as what actually? This phenomena is called as punch through or breakthrough. Right? Write down. Write down this. When the reverse voltage is made to very high, when the reverse voltage is made to very high, then when the reverse voltage is made to very high, then the depletion is in fully occupy the base. The depletion is in fully occupy the base. Fully occupy the base. Fully occupy the base. Due to which effective base width becomes 0. Effective base width becomes 0. Effective base width becomes 0. And also maximum power is dissipated, and also the maximum power is dissipated, maximum power is dissipated within a depletion region, which may cause the overheating of the transistor, and transistor gets damaged. This phenomena is called as punch through or breakthrough. This phenomena is called as punch through or breakthrough. Right. This is about early effect or base width modulation. Right? Yeah. Thank you. To be continued in next lecture.